You know that feeling, right? That moment when everything just has to click into place before you can actually move forward.
Oh, yeah, like you're waiting on multiple things.
Exactly. Maybe you're trying to launch a project, but you're stuck waiting on, say, final approvals from two different departments.
Mm-hmm. Or maybe cooking. You can't start mixing until all the ingredients are prepped.
Right. That specific point where multiple conditions are met, and then the next step happens. That's actually what we're digging into today.
Sounds intriguing.
Welcome back to the deep dive. Today, we're plunging into a concept that's, well, quietly foundational to so much of our automated world.
Okay.
We're going to unpack something called EREND. It's a really powerful but kind of elegantly simple tool from industrial automation.
Errand. Got it.
So our mission here is to figure out what EREND actually is, why it's so critical for complex systems, keeping them running smoothly,
And how it works, presumably.
and how it works, how it ensures everything from factory robots to crucial safety mechanisms
Mm.
operate precisely perfectly synchronized.
It's all about timing and conditions meeting up.
Exactly. It's the ultimate gatekeeper for events and processes.
Mm-hmm.
A fundamental challenge, really, not just in factories, but in lots of areas.
True.
And we've pulled together insights from technical docs and research papers on the IEC 61499 standard to help us explore this. So, yeah, let's dive in.
Great. It's quite striking how a concept that really boils down to a logical AND can have such, well, huge implications for reliability and safety.
A logical, Andy. Okay.
Yeah, and EREND comes from IEC 61499. That's a global standard for designing control applications and automation.
Like a blueprint for the brains of these systems.
Pretty much, yeah. And in this standard, events aren't just things that happen. They're absolutely central. They control how information flows, how different parts synchronize their actions.
Okay, so events are the signals, the triggers.
Hmm.
And EREND manages those triggers. So what is EREND fundamentally? You mentioned and.
Right. At its core, ERN stands for rendezvous. And it really is just that, a logical AND connection for events.
Rendezvous, like a meeting point.
Exactly. Imagine a point in a process where you need several different signals or pieces of info to arrive basically at the same time before you proceed. That's END. Think of it like a specialized junction box.
So it's not just one signal kicking things off, but a specific combination. That's the waiting game you mentioned.
That's it. ERN waits for the simultaneous occurrence of two or more specific input events.
Yeah.
We usually call them EI1, EI2, and so on, event input.
EI1, EI2. Makes sense.
And these inputs can come from completely different places, different function blocks.
Function blocks.
Think of them like reusable software modules, little building blocks, kind of like specialized Lego bricks engineers use to build complex control logic.
Ah, okay. So one input could be from a sensor.
Exactly. Another from a motor, maybe another from an operator pushing a button, different sources.
Well, so how does the actual rendezvous part work, the synchronization?
Well, the really crucial part is the synchronizing act. The output event, we call it EO for event output. It's only triggered when all the input events, EI1, EI2, maybe more, that you've set up for that ERN block are activated.
So all of them.
All of them. If only one event shows up, nothing happens. Absolutely nothing on the output side.
It's really an all or nothing deal.
Precisely. It ensures every single prerequisite is met. And once it is triggered, that EO, the output event, gets passed along to the next function block or action down the line.
Kicking off the next step.
Yep. It's the green light, but only when, every condition is met simultaneously.
Okay, I think I get it. It's not about which event arrives first, but the fact that all of them are there. It's a checkpoint, not a race.
You've got it. That's the essence of the rendezvous.
And I saw something about a reset input, too, an R input. That sounds pretty important for keeping things running.
Oh, absolutely vital. Yeah, the R input stands for reset. This lets you basically reset the block back to its initial state.
So telling it to wait again.
Exactly. Telling Aaron, okay, maybe the last cycle finished or maybe something went wrong and we need to restart. Go back to the start and wait for all those events from scratch again.
Right. Crucial for repetitive tasks.
Absolutely. For systems that need to repeat processes reliably, making sure each cycle starts fresh from a known, safe state.
So EREND is really this key piece for making sure everything is perfectly aligned before taking action. That moment of readiness.
That's a great way to put it.
So where do we actually see this in the real world? This kind of precise synchronization seems incredibly useful.
Oh, it's everywhere in automation. One of the main uses is synchronizing parallel processes.
Parallel processes, like in a big factory.
Exactly. Think about a large manufacturing plant. You often have multiple things happening at once independently, but they need to align perfectly before the next stage.
Okay, can you give us a concrete example, maybe with robots or assembly lines? That usually helps visualize it.
Sure, sure. Imagine you have an industrial robot that needs to pick up a part, right? And there's a conveyor belt bringing that part.
Okay, robot and conveyor.
The robot needs to be in the right position, the conveyor belt needs to be stopped in exactly the right spot, and maybe a sensor needs to confirm the part is there and oriented correctly,
Three things, potentially.
at least. Erin makes sure all those ready signals or events happen, robot in place, conveyor stopped, part sensed, and only then does it send the EO the signal for the robot to actually grip the part.
Ah, I see. So it prevents the robot from moving too early or the belt moving away.
Precisely. It ensures efficiency, smooth flow, and prevents costly errors or collisions.
That makes total sense for efficiency.
Yeah.
But what about safety? That seems like an area where this all-or-nothing idea would be critical.
You're spot on. That's another really vital application. Safety critical systems.
Okay.
Here, Erin's job is to ensure multiple independent safety conditions are met before anything potentially hazardous happens.
So not just making things run well, but actively preventing accidents, protecting people.
Exactly that. For instance, think about a big, heavy industrial machine. You absolutely don't want it starting unexpectedly.
No, definitely not.
So it might only be allowed to start if, say, the emergency stop button is released and a protective cover or door is fully closed, and maybe a light curtain safety sensor confirms no one's reaching in.
Multiple checks.
Right. Erin provides that logical and-y.
Yeah.
All those conditions must be true simultaneously before the machine gets the signal to power up or start its cycle.
And if one condition isn't met, like if the cover is slightly ajar.
Then the Erin block simply doesn't trigger the EO. The machine stays off. No ambiguity.
That's huge.
Yeah.
So what are the risks if this isn't done right in safety systems? What are the pitfalls?
Well, the pitfalls are serious. If that synchronization fails, or if it's poorly designed, maybe relying on just one signal when multiple checks are needed, you could have a machine starting while someone's hand is inside, or operating with a safety guard open.
Leading directly to accidents.
Directly. The risk is complacency, maybe cutting corners, not having enough independent verification points feeding into that AND logic. Erin, used correctly, directly boosts reliability and, crucially, human safety.
Wow. Yeah, that really highlights its importance. It's about building in those fail-safes. What about more complex scenarios, like systems spread out over different areas?
Good question. That leads us to distributed control systems.
Okay, distributed, like
Yeah.
not all in one place.
Exactly. You might have multiple controllers or smart devices working together, maybe even in different buildings or sites. Erin helps synchronize events between these separate components.
How so?
Imagine a big logistics system. Maybe multiple automated guided vehicles, AGVs, and sorting systems need to confirm they've completed their tasks before a large shipment is released to the next zone.
Ah, coordinating across different machines or areas.
Right. Erin can act as that central coordination point, ensuring all the necessary ready signals from these distributed parts have arrived before triggering the next overall step. It orchestrates the whole thing, even across distances.
Okay, that makes sense. So looking at the big picture then, what are the main advantages of using EREND? What makes it so indispensable?
Well, there are several key ones. First, as we've seen, is precision. It allows for really exact synchronization of events, essential for complex systems where timing is everything.
Microsecond differences matter kind of thing.
Absolutely. Second, it's surprisingly flexible. We keep talking about two inputs, EI1 and EI2, but you can configure EREND to wait for 3, 4, or really any number of input events.
So it scales up for more complicated situations.
Easily. It meets very complex synchronization needs without needing fundamentally different logic.
That's a big plus. But I wonder, is there a downside? Could this all-or-nothing logic be too rigid sometimes? Like, what if one signal is always really slow? Could it hold everything up?
That is an excellent point. And yes, that's a critical design consideration. While EREND gives you that certainty, you're right, it can create a bottleneck if one of the required events consistently lags behind the others.
So the whole process gets slowed down by the slowest link.
Exactly. The system will just wait. So engineers have to carefully analyze the timing characteristics of all the inputs feeding into an EREND block. You need to ensure you haven't inadvertently designed a system that's perpetually waiting because one condition is inherently slow.
So there's a trade-off. Certainty versus potential delay.
There can be. But moving on to other advantages, that very ND connection gives you uniqueness and certainty. Without a doubt that the output event EO only fires when all conditions are met. No false starts, no
That
ambiguity.
reliability factor again.
Definitely. And finally, it offers remarkable simplicity in how it's implemented, especially within the IEC 61499 standard.
Oh, how so?
It can be easily modeled just as a standard function block. You just drop it in, connect the event inputs and outputs. You don't need to write extra complex custom code to achieve this synchronization logic. It's baked into the standards framework.
That's clever. Makes it much easier for engineers to use consistently and correctly.
Right. So you get
Yeah.
precision, flexibility, that certainty, and simplicity of implementation.
And thinking about it, those advantages directly lead to systems that are more robust, much safer, and generally more efficient. It really impacts everything from the stuff we buy to, well, the safety of the people making it.
Couldn't have said it better myself.
Okay, let's try and crystallize this with a really simple example, maybe something outside of a factory, like multi-factor authentication for logging into a secure website.
Oh, that's a perfect analogy. Yeah, let's run with that.
So you type your password.
Okay, so the signal correct password entered, that event would connect to, say, EI1 on our conceptual END block.
Right, and then you get that code on your phone.
Yeah, so the signal correct security code from phone entered, that event connects to EI2.
Okay, password to EI1, phone code to EI2. So when do you actually get logged in? When does the AO fire?
The output event, EO, the access granted signal, will only be triggered when both EI1, correct password, and EI2, correct phone code, have occurred.
So right password, but wrong code.
Nothing happens. EI end waits.
Right code, but maybe you mistyped the password.
Still nothing. EO stays silent. Only when both signals arrive, confirming both conditions are simultaneously met, does EREND finally trigger that EO and let you in.
Perfect. That really clarifies the core AND logic in a context that most of us deal with pretty regularly.
It shows how fundamental that synchronization pattern is.
So wrapping this up,
Yeah.
we've really gone deep on EREND today, this elegant little concept for event synchronization.
Little block, big impact.
Yeah. We see it's not just some obscure technical detail in automation. It's really a cornerstone for ensuring precision, coordination, and reliability in all sorts of complex systems. Factories, sure, but maybe even beyond.
It really is a powerful example of how a seemingly simple logical gate, basically an AD gate for events, underpins so much complex interconnected technology around us.
It's working away behind the scenes.
Everywhere, often invisibly.
And maybe as you, our listener, think about this, consider how similar kinds of logical synchronization might be working in places far beyond industrial controls or even online security.
Yeah, like, are there parallels in biology? Maybe multiple chemical signals needing to arrive at a cell before it reacts.
Or even in, like, big organizations.
Yeah.
Complex workflows where, several teams have to finish their part and sign off before a major project moves to the next critical phase.
Absolutely. And think about the flip side, too. What happens when these critical synchronization points fail? Or if they aren't designed robustly in the first place?
The potential for cascading failures.
Exactly, especially in highly interconnected systems. So how vital is it really to understand and properly design these seemingly simple but fundamentally crucial logical checkpoints, whether we're talking factory robots or login systems, or maybe even those biological or organizational processes?
Definitely something to chew on. A lot relies on things happening together at the right time. That's a great thought to end on.